This video explained how to draw shear and moment diagrams for a simply supported beam with a moment and distributed load acting on it. Before we can draw the diagrams, we must solve for the resultant forces. We can simply solve the resultant force at B first by summing the moments around point A. The distributed load is able to be converted into a point load by multiplying it by the beam length. After solving this equilibrium equation, the force at point B comes out to be 3,040 pounds acting in a positive upwards direction. The force at point A can now be solved by summing the vertical forces acting on the beam, and it comes out to be 2,960 pounds. There are no forces acting in the x direction, so the horizontal force at A will be equal to 0. Now that the resultant forces are calculated, the diagrams will be drawn by plotting points from left to right, followed by connecting them. Shear forces acting on the beam are simply the vertical forces in this case, so we can start by plotting the force at point A first. The shear force at the other end of the beam will be the magnitude of the first point subtracted by the area of the distributed load. A key concept to remember when drawing these diagrams is that a change in magnitude will equal the area of a previous diagram. The shear on the right side of the diagram checks out because it matches with the vertical force at point B. Before the moment diagram is drawn, the dimensions where the shear is equal to 0 are needed. The slope of the shear line is the magnitude of the distributed load on top of the beam, so a simple proportion is able to be set up. The dimensions come out to be 7.4 meters from the left side of the beam and 7.6 meters from the right side. Finally, to draw the moment diagram, we start by plotting the moment acting at point A. The next point or point of maximum moment at 0 shear is found by adding the area of the positive shear triangle to the moment acting at point A. The moment on the far right side of the diagram will then be the maximum moment subtracted by the area of the negative portion of the shear diagram. The moment diagram now checks out because the last point is 0 and there is no moment acting on the right side of the beam.